Look, the world is changing. It's changing fast, like really fast. And this change isn't about a new phone or a faster internet connection. This is bigger. We're talking about machines that can think, not just calculate, but think. We call it artificial intelligence, or AI, and it feels like it just showed up one day, right? Like you blinked and suddenly your cousin is using an app to write his wedding vows. But this story didn't start yesterday. It's a long, winding road, a timeline that stretches back decades. This is the story of how we got from simple calculators to something that can write a movie script. It's a story about us, about our future, and about the choices we need to make right now. This isn't about scaring you. It's about preparing you. Because what's coming next? It's going to be a wild ride. Let's begin the journey. Let's wind the clock back and start at the beginning of our timeline. A long, long time ago, in a galaxy not so far away, actually, right here on Earth, we built tools to help our hands. We made hammers, we made wheels. Then we got a little more ambitious. We built machines to help our muscles, like the steam engine, the factory loom. For centuries, that was the deal. Technology was about physical power. But then, a new idea started to take root in the 20th century. What if we could build machines to help our minds? This was the dawn of computing. The first computers were giants. They were hulking beasts of metal and wires that filled entire rooms. Colossus ENIAC. They were amazing for their time. They could perform mathematical calculations at speeds no human could match. But let's be clear, they weren't smart. They were just incredibly obedient. They followed rules. A programmer, a human, would write a very specific, very detailed set of instructions. If you told it to add 2 and 2, it would give you 4 every single time. So the old way of spoon-feeding rules to a computer didn't work for complex problems. The AI winter was cold and long. But in the quiet corners of research labs, a different idea was taking shape. Instead of telling a machine exactly how to do something, what if we could just show it? What if a machine could learn on its own, just by looking at examples? This was the revolutionary idea behind machine learning. It's not about programming a machine with rules. It's about training it with data. It's the difference between giving someone a fish and teaching them how to fish. But for computers, think about it like this. You don't teach a toddler what a dog is by giving them a rule book. A dog is a 4-legged mammal. 4-legged, fur, a tail, a wet nose. You just point at dogs and say, "Dog." You show them big dogs, small dogs, fluffy dogs, short-haired dogs. Over time, their little brain starts to recognize the pattern. That's the core concept of machine learning. We feed a computer thousands or even millions of labeled examples. This is a dog. This is not a dog. The algorithm adjusts itself, finding subtle patterns humans can't articulate. This approach wasn't magic, it was math. Sophisticated statistics, probability, optimization, all running on increasingly powerful computers. The next big jump felt like it came out of a science fiction movie. It's called deep learning. Deep learning, giving a computer a brain, a simplified digital version of a brain. It's based on an artificial neural network, inspired by neurons in our heads. A stylized diagram of a neural network. Inputs, hidden layers, outputs. Not one layer, many, many layers, a deep stack. Each layer recognizes something simple, then passes it on. Let's go back to our cat example. The first layer might learn edges. The first layer might learn colors. The next layer might combine edges into a simple curve, or a corner. The layer after that might build features like an eye, or an ear, or a whisker. The final layer takes those features and makes a conclusion. Based on those, there's a 98% chance this is a cat. The deep part is this hierarchy, building from simple to complex on its own. What unlocked the power of deep learning? 2 things. First, big data. The internet created a planetary-scale library of text, images, and videos. Suddenly, massive datasets were available for hungry algorithms. Second, processing power. GPUs. The same chips that make video games look great turned out to be perfect for parallel math. With massive data and supercharged hardware, deep learning didn't just work, it worked spectacularly. This was the big bang for modern AI. Models started crushing human-level benchmarks. They became the best at recognizing objects in photos. They learned to translate languages. They could transcribe speech better than professionals. And that brings us to today. It brings us to the tool that put AI on every dinner table and in every news headline, ChatGPT. So, what is it really? Put simply, ChatGPT is a deep learning model. It's incredibly good at one thing, predicting the next word. That's it. That's the secret. A super-powered autocomplete. But when you train a model on a truly mind-boggling amount of text, basically a huge chunk of the internet, books, articles, predicting the next word starts to look a lot like understanding, and writing, and even reasoning. It works like this. You give it a prompt, a question, a command. Example, write a poem about a lonely robot. The model calculates the most probable next word. Maybe it's in. Then inner predicts world. In a world of predicts steal. It strings together likely sequences to fulfill your request. It's all patterns, no consciousness. So why does this matter? Because it changed how we interact with computers. For the first time, we could talk to a machine in our own language, in natural human sentences, and it could talk back. It could explain complex topics. It could brainstorm ideas. It could write code. It could draft emails. It democratized AI. You no longer needed to be a programmer to use it. You just needed to know how to ask a question. ChatGPT and other models like it are amazing, but they are still considered narrow AI. They are incredibly good at a specific task, like generating text, creating images, but they can't do things outside of that narrow domain. You can't ask ChatGPT to go make you a cup of coffee. It doesn't have a body. It doesn't understand the physical world. It can't reason about things it wasn't trained on. This is where the next, much more speculative, chapter of our timeline begins. This is the quest for Artificial General Intelligence, or AGI. AGI is the holy grail of AI research. It's the idea of a machine that has the same breadth of cognitive abilities as a human being. An AGI wouldn't just be good at one thing. It would be able to learn, reason, plan, solve problems across a wide range of different domains. It could learn to play the piano, then figure out how to cook a new recipe, then have a philosophical debate, all with the same underlying intelligence. It would be able to transfer knowledge from one area to another. It would in essence think as flexibly and as generally as we do. We are not there yet. Not even close. Creating AGI is an astronomically difficult problem. If we cross the AGI threshold, the timeline might speed up exponentially. An AI as smart as a human could improve its own code. It could design better AI, leading to a recursive loop of self-improvement. Slightly smarter AIs create much smarter AIs, which then create vastly smarter AIs. This event is called an intelligence explosion. The result is superintelligence. A mind qualitatively smarter than the brightest humans. Hard to imagine what that would be like. Like a chimp trying to understand quantum physics or human economics. The gap would be that vast. Superintelligence could solve centuries-old scientific mysteries in minutes. It could invent technologies we can't conceive of. Cure aging, unlock interstellar travel, understand the fundamental nature of the universe. Benefits could be practically infinite. It could start a golden age, but risks are equally infinite. Alignment becomes critical. A superintelligence would be the most powerful force on Earth. Its goals would matter most. Misaligned goals could be catastrophic. It wouldn't have to be malicious. It might treat us as irrelevant obstacles, like ants under a highway. So, here we are, at a pivotal moment on the timeline. We've journeyed from simple rules to deep learning, from ChatGPT to the theoretical edge of superintelligence. It's a lot. It's exciting. And yeah, it's a little scary. The story of AI is no longer a niche topic. It is the central story of our time. It's going to change everything. How we work, how we create, how we learn. Some jobs will disappear. New, unimaginable jobs will be created. We have to be ready to adapt, learn new skills, Redefine our relationship with work. Action starts with understanding. You don't have to become a coder or an AI researcher, but you do have to become literate in this new language. Ask questions. Be curious. Read. Challenge the hype. Demand transparency from the companies and governments building these tools. Ensure technology serves humanity, not the other way around. Prioritize human well-being. Prioritize creativity. Prioritize connection. The future is not yet written. The timeline to tomorrow is not a fixed path. It's a branching set of possibilities. Which path we take is up to us. Build AI that is open. Build AI that is safe. Build AI that is equitable. Update education, critical thinking, emotional intelligence, creativity, collaboration. Create regulations and safeguards. Protect us from risks. Harness the immense benefits. This is our collective responsibility. This is a call to action.